You heard me mention facades quite a bit already, and we also use them in few places, so I think it's time that we understand what facades are and what they are not. First of all, Laravel Facades and the Facade Design Pattern are different things. The Facade Design Pattern provides simplified interface to set of complex classes or code. The goal of the facade pattern is basically to make a subsystem easier to use by providing a unified high-level interface. In Laravel, the facades provide a way to access methods of the classes from the service container in a static way. So facades kind of serve as static proxies. They proxy the static calls to the underlying actual class methods. So while both the facade design pattern and Laravel facades aim to simplify complex systems and may have some similarities, they are different in its purpose, implementation, and usage. So let's look at our web routes file. As you can see here, we are using the route facade and we are calling the get method statically on the route facade, which is just a PHP class. If we inspect the route class, we see that it does not have static get method defined. This is where the most confusion usually comes from, because we're calling the get method statically and this method doesn't exist on the route class, in this case route facade. Some might even argue that facades resemble and use static methods, but in reality they're not static methods. In fact, no such method exists, as you can see in here. So how does it work? Let's try to understand it. We're extending some parent class here called facade, and we're defining this getFacadeAccessor method, which returns string router. Now, without even digging into the parent method, I think there is one thing that is clear here. We're calling a method statically, and that method's definition does not exist in here, but yet it still works. Now, what have we learned in PHP that allows us to do such magic? If your answer was PHP's magic methods, you are absolutely right. Remember, we have the call and call static magic methods that get invoked when inaccessible methods are called on objects, depending if the method is called using the static operator or not. So now knowing that, we should expect to find call static magic method definition somewhere in the parent class, because it's not defined in the route class in here. So let's check it out. Let's open the facade here. Let's scroll down. There are some methods here related to testing facades. Let's keep scrolling. And right here at the end of the class, we see this call static magic method. So again, if you call a static method on an object that is not accessible, it will invoke the call static magic method if the call static magic method is defined, and that is exactly what's happening in here. When we're calling the route get method statically, the get method doesn't exist on the route class, it doesn't exist in the facade class either, and therefore it invokes the call static method. And then as you can see, we're trying to get the instance of the object and we're calling the method on that object, passing through the arguments. Now let's see how this instance is retrieved. So let's dig into the getFacadeRoot method in here. We see that it's calling this getFacadeAccessor method and passing that value as an argument to the resolve facade instance. And this getFacadeAccessor method is defined within the facade in here. So within the route facade, we have that method and it's returning the router string. So in here, the router string is being passed to this method. So let's continue digging into it. And here we can see that it first checks if the instance has been resolved already. If it has, it just returns that. If not, then it's trying to get the instance from this app object or app variable. Now remember that the application object or the application class is the container itself. So essentially it's trying to resolve the class from the container. Now, how does it do that with the array access, right? We're not calling make or resolve method. It's just trying to get this class from an array of the app object. So let's dig into the application class again. So let's open the application from the foundation directory. Let's scroll all the way up here. Again, we see that this extends the container class. So let's open that. And as you can see, the container implements array access. This means that we can interact with this object as an array and access its elements. As you might remember, array access provides various method definitions. The important one here is the offset get. So let's see the implementation of the offset get method in our container. So let's search for the offset get. And as you can see, if you try to access a class as an array element on the container or the application object, it simply calls the make method on it. And if we go into the make method, we see that this calls the resolve. So basically in here, we are essentially trying to resolve this class from the container. And we can actually test that out to make sure that what I'm saying is correct. So let's open web.php, and in the home page, let's do something like we're going to get the application object, and let's try to resolve some class. Remember, we have the payment processor provider, which binds the payment processor interface to Stripe concrete class. So let's try to resolve that payment processor class in here using the array access. So we'll do payment processor and class, and let's assign this to payment processor like this, and let's die and dump payment processor just to see what we get. Let's open the browser, let's refresh the page, and sure enough, we see that we're getting the Stripe object. Now, of course, Laravel does some caching in here to optimize this, but in a nutshell, that's what's happening. We're trying to resolve the class from the container. So as long as the class is resolvable by the container, it will work whether it's an alias or a fully qualified class name. Now, as you noticed in here, in the route facade, we are returning string router. And then in here, we are trying to resolve that using the router string and not the fully qualified class name. This means that the router string is kind of like an alias registered in the container. It's basically an alias for the router class. So this get method right here is the get method on the router object. So if we open the router class and search for get, we see that this is the method that gets invoked when you do route get. In fact, let's try to dump the URI here and then open the browser to confirm. Let's refresh the page, and sure enough, we're getting these routes. So we have the up route, the home route, documents, create, transaction, and so on. Now you might be asking, why do we have two slashes here, and why do we have /create and not /transactions/create? As you can see, these routes are not prefixed. That's because we are calling the dump within the get method, which basically just registers this route, but then it adds the prefix somewhere else later on, not in here. But as you can see, this get method is what's invoked when we call the get method on the route facade. This means that somewhere in Laravel framework, there should be binding for this router string. Now that's easy to find. We can just search for the router string and find where it's used in the Laravel framework, and then understand from there which one is basically binding things into the container. But I'm just going to show you where that is. So in the application class, if we scroll down to the constructor, so let's keep scrolling to the constructor, we have this register base service providers method. If we click into that, one of the service provider here is routing service provider. So if we go into that routing service provider, we have the first method in the register method called register router. And as you remember, the service provider's register method is used to bind things into the container. So all of these are basically binding stuff into the container, like the URL generator is binding URL string to the URL generator class and so on. So the register router method is binding this router text or the string to this router class. So that's where it's instantiating the new router object, and it's using the singleton or the shared binding. So now you understand that when the get method is called on the route facade, the router class is resolved from the container because this router is bound to the router class right here. And then the get method, this get method gets proxied to the router object or the router class. So basically, Laravel Facades provide access to objects from the container. It serves as a proxy for accessing the methods of the underlying object that is resolved from the container. So this getFacadeAccessor method should basically just return the name of a service container binding, whether it's a fully qualified class name or just a regular string like router. Now, Laravel does provide plenty of facades out of the box, but in addition to that, we can also create facades ourselves. Let's maybe make a facade for the payment processor class. So we're going to go to the directory. Maybe let's create a new directory here called facades. And let's add a new facade in here. We'll call it payment. And this needs to extend the base facade from the support directory. Now, this on its own, of course, is not going to work because, again, we need to define that getFacadeAccessor method. So let's define getFacadeAccessor method here, and we're going to return payment processor fully qualified class name. Let's close this out. And then in our web.php, let's simply use that payment facade. So we'll do payment and then call process on it. And the process method, again, is going to be proxied into the Stripe implementation of the payment processor interface. Let's remove the dumps from the router here because we're dumping that URI in here. Let's get rid of that. Let's actually close all of these things from here. Let's open the browser. Let's refresh the page. And sure enough, we see that it works. So again, this process method is being proxied to the payment processor implementation, which is the Stripe class, because that's what we're binding the payment processor to. Now, if we didn't define this, right, if we didn't define the getFacadeAccessor, we would get an error. So if we open the browser and refresh the page, we get an error that Facade does not implement getFacadeAccessor method. Now, if we return the string here instead of the fully qualified class name, we would get an error. So let's say we return something like payment processor and we refresh the page, we get an exception stating that target class payment processor does not exist. Now this makes sense because Laravel does not know how to resolve this payment processor from the container. We haven't told Laravel anything about payment processor. Remember, the reason the router string worked is because there was a definition or the binding of that router string in the container. That's why it worked. But we don't have a definition of payment processor in the container. We're not binding this string to any implementation. We're binding the fully qualified class name. If we replace this with payment processor, then it's going to work. But since this is deferred provider, we need to run the clear compiled artisan command to clear the cache. So we'll do clear compiled. Let's open the browser, refresh the page, and we're still getting that error. Oh yeah, I forgot to update the provides method here because this provides the fully qualified class name. Instead, it needs to return the payment processor because that's our binding here. Let's run the clear compiled again. Let's refresh the page. And now, as you can see, it works as expected because now Laravel knows when we ask for the payment processor from the container, it knows how to resolve this class because of this binding. Now, what if you wanted to have both ways? What if you want to be able to access the payment processor using the fully qualified class name as well as the string? We can do that by using aliases. So we can change this back to payment processor, and then we can say that the payment processor also has an alias of payment processor, like so. And then we need to return that in here as well as an additional string. So now if we run the clear compiled and go to browser and refresh the page, we see that it still works. And it would still work if we replace this with payment processor fully qualified class name. Refresh the page and it still works. Alright, so to reiterate this again, Laravel facades do not define static methods. They just proxy static method calls to the underlying objects that are resolved from the container. Laravel facade is also not the same thing as the facade design pattern. And this might be confusing to some because you might know what facade design pattern is and you might be thinking that Laravel does not follow that facade design pattern. Laravel facade is more like proxy pattern than an actual facade design pattern. It's just named the same way and may have some similarities. Facade name itself for Laravel facades does make sense if you think about it. But facade design pattern essentially just provides a simple interface with interacting multiple complex classes or a system. It basically hides the complexity of the system and provides easy-to-use interface. Let me give you an example or an analogy of what a facade is. In construction, brick veneer is used to give the appearance of a solid brick wall, but the actual structural support comes from different, more complex underlying systems such as wood or metal framing, the concrete, and so on. This is the complex or the messy part of the building that requires more knowledge to understand and work with. Similarly, in software, we often have multiple complex subsystems like payment processing, user management, etc., that perform essential tasks but are complex to deal with directly. The brick veneer provides a simple, clean, and aesthetically pleasing outer surface, hiding the complexity of the actual structure and presents a polished, easy-to-understand front. It's the front face of the building, it's what people walking by see. It has no functionality of its own. In the facade design pattern, this is equivalent to the facade class, which hides the complexities of interacting with multiple subsystems and provides a simplified interface. Laravel facades, while may seem similar to it, are not the same. They do provide an easy interface but are just static proxies allowing you to interact with the underlying object that is resolved from the container. It does not give you access or an interface of multiple complex subsystems. So that's where some of the confusion might come from, that you might think Laravel facade is the facade design pattern implementation, when in reality it really is not the same thing as the facade design pattern. It is more like a proxy design pattern, in my opinion. Now, the question is, why and when would you want to use Laravel facades? In my opinion, you should not need to use facades for the most part, outside of some of these major facades like route, cache, config, db, auth, and so on. You can see the list of available facades along with their underlying classes in the documentation, but for the most part, you should not need to use facades. You can get access to the underlying class directly by injecting it as a dependency yourself without relying to the facades if you wanted to. So instead of doing this in the web.php, we could just inject the payment processor contract or an interface, and this will work because Laravel will automatically resolve that, right? And the same goes for other things, like instead of using the view helper function, right, we could use the view facade to do the same. So we could do view and then make, and this is going to do the same thing as that view helper function. So let me actually remove this and remove this and refresh the page here. We see that it works just fine. And if we inspect this view facade, we see that it has no make method. It returns the view facade accessor, which is just the name of the container binding. And then if we open maybe view service provider, we should see the register method in here. So we have this register factory, and we see that this is where the view is registered or bound in the container. And it just returns an instance of this factory class, which is gotten from this create factory method, and it's just the factory from the illuminate view namespace. So when we call the make method in here, this make method is proxied to this factory class. So if we search the make method here, this is the method that gets called. So we can do dump view here and then open the browser and refresh the page, and we see the welcome view being printed in here. So again, this make method is what gets called when we do call the make method on the view facade. It just proxies that to the underlying implementation. And alternatively, instead of using the facade, you could just inject this factory in here and it would still work. So we could do factory view and simply do view make, and this is going to work just fine. If we go here and refresh, we see that it works. In addition to that, we can also simply inject the interface that this factory class implements. We see that this factory implements factory contract, and this is just the factory from the Illuminate contracts view. So within our web.php, instead of injecting the Illuminate view factory, which is the implementation of the factory contract, we can just inject the factory interface instead, and it will still work. So let's find that one in here. We need Illuminate contracts view factory, and let's open the browser, refresh the page, and it still works. And the reason this works is because both the factory contract and the factory concrete class are the aliases of this factory class. If we open the application class in here, we should be able to find a bunch of aliases. So let's search for alias here. And remember, we went over the register-based service providers. And right below it, we have this register core container aliases. If we inspect that, we see that we have a bunch of aliases here. So we have the one for router. The router has aliases of router and register and the binding register interface. And then we have the view that has aliases of the factory and the factory interface. So either of these can be injected and it will resolve the same view string, which is bound to the proper factory class. Same goes for the router and all the other aliases in here. So in my opinion, dependency injection is better and I would recommend using that, but using facades are not wrong either. You can use facades in some cases, like this might be overkill for most of the cases. You can just use the view helper function, which does that for you, or the view facade if you prefer that. And you might be asking the question of, isn't dependency injection better for testability? And the answer is yes. But facades do have methods available that make it easier to mock and write tests for it. So writing tests for methods that use facades usually are not an issue. So I would simply advise to keep the scope of your class in mind when using facades. Try not to use every available facade in a single class. Basically, try to avoid overusing the facades and the helper functions. In some cases, it's totally fine and you'll see me use them as well, like the route here makes sense to use. In some cases, the cache facade might make sense, and so on. I would advise to try and not fight the framework too much and sort of embrace the framework. Use the features available for you. If you don't like it, then use the alternative. Thankfully, Laravel does not force you into using one or the other. You can make that decision for yourself and your project. But as with anything else, keep scope in mind and don't overuse things.
Better learn balance. Balance is key.
Also, I do want to mention that facades do confuse IDEs and code editors. It makes it hard to click through methods. For example, this route get is clickable, but it brings you to this route facade because it has these methods defined in this documentation. But it does not take you to the get method of the actual router class, which is where it's defined. Alright, so this is it for this episode. Thank you so much for watching. If you like my videos, please hit the like button and subscribe to the channel if you haven't already done so. Until next time, happy coding.